Good afternoon, everybody. Hello, Cleo. Good afternoon. This is the makeup class for week 5, the Easter holiday, which we will cover some concept about switching. We have done with the application layer, transport layer, then we move to the IP layer or network layer, layer number 3, and we jump into layer number 2, the data link layer. Within the data link layer, as we covered last session, can you guys hear me or not? My voice is clear or not clear? Please let me know. Yep, thank you. Excellent. Okay, so what we have, we have switches. In previous class, we did have comparison between the hubs and the switches. We have two devices, hubs and switch. And we mentioned that hub is a dumb device because usually hub has what we call it one collision domain. However, switch came with a better version. So what's the advantage? Why we prefer switches over hubs? That's what we will discuss today. Switches usually something similar to that. You have ports, usually in most cases. The 2960 is 24 ports, but if you go for HP or other models, you may have different, but mostly based on 24 multiplied 24 ports. So what's the good thing with that? Why we prefer usually to work with switches? So to do that, you need to understand how we link two devices together first. If I want to link two devices together, I can use what we call it hub. Hub has a problem, which is it has something called one collision domain. What do you mean by that? I mean by that, if I have two frames try to get into, let's say, to other destination and they clash or collide, what happened exactly? Everybody in that hub will be affected by that collision. Collision domain, if you want to understand it in an easy concept, it's all the devices which will be affected when a collision happens. So if a collision between two packets, two frames has collide, how many devices will be affected? Those devices, we call it collision domain. With the hub, all the devices, all of them will be affected. So, which means that we have one collide domain in the whole device. So, if two frames or two packets collide, is that what's going to happen? Oh, it's going to go through a new process, and that new process, which is involved listening, then sensing, then sending. In switching, we use something called CSMA, collision detection, CD, carrier sense multi-access protocol. So that's usually based on hold, sense, then take initiation, and then start sending and all those. What does that give me? Delay, a long delay. So which means that when we use hubs, expect that your connections usually it has a delay. And we have another calculation which can show you that it's only 37% of the traffic will go through non-problem and the rest will be a problem, but away from your study here. So what about the switch? What will happen with the switch? Watch that. I have PC 1, 2, 3, 4. Watch. So no collision, no colliding. Why is that? Because each link, which you will see, or you have seen that before, I did a demo last session about that. We can show you again. Every port link to a device. So, which means that if I have something like this, that's FA from FA1 until the 24. So if I went over here and that's my switch, for example, and I put PCs over here, that those PCs, each one will be linked. That's number one, for example. That's number two. And that's number three. Put whatever the numbers you like. The idea of that is those PCs are separated. So each one has its own collision domain. So if something happened to one of those links or ports, what it affect that ports only, that port only. So only that port will be affected. Yes, only that port will be affected. The other port has nothing, no problems, whatever. And that one we call it isolation. Isolation means like I have port number one has no problems to do with port number two or port number three or port number four. Yes, they can communicate and everything, but if I shut down port number two, has nothing to do with one or three. If I enable or disable, if I connect a device, didn't connect a device, it didn't affect any other device on the switch. Switch is much faster, better, and has a lot of advanced, let's say, techniques. We will cover some of those ones. So collision domain, that's one thing. Isolation, that's another thing between the switch and the hub. Okay, how can switches we move the data between one to another, one device to another device? Well, switch usually has, let me just show you in my own material. Switches usually has a motherboard. We call that fabric. Okay, so how the data works exactly? Oh, easy. So the data usually come from a port going on through another port. For example, here fast 0, 1, this one fast 0, 10, or 4 or 5, whatever it is. So how the data goes through the fabric? or through the motherboard, and we call it motherboard. So we have three different approach. We mention two only on the CQ material for this week. However, I try to get you three of them and the full material so you be aware of those ones. The data, the old technology data, when they invent the switches and the devices, it based on what we call it memory. The memory. If you want to switch, you have to go through the memory. What does that mean? Here it is. You have a packet, want to go from here to here. It has to go inside the device, loaded fully inside the memory, the CPU and everything. Yes, and RAM, or then move again all of it to the ports which been target. So what does that mean? You can actually process one request or one go through per time. So if one coming here, what about the second one? Has to wait. And we call that queuing. So the old technology, which the memory, that switching fabric, it has to go through the memory. And that's usually slow, has a delay. The delay, we have an equation, by the way, we call that L by R, the transmission delay. We have something called transmission delay and propagation delay. The transmission delay, L, which is the length, by the R, that's the bandwidth or the speed. You guys call it speed. So if we go L by R, the longer the L and the less the R, the longer the delay. So they improved that later on to something called bus fabrics. So what is the difference between that? You don't have to go all of it to the memory. So you have something common between area which common between all the ports. You put that into the port and it will take it over there. However, that's only still one device can process a time. So if I want to process the second one, you have to wait until this one process and then finish. Then they come up with the latest one, which is what we call that the interconnection network. And that's, as you can see, that's something like that. It's interconnected. That one allow multi-ports to send the multi-data to multi-output. So multi-in, multi-out at the same time. As you can see that I have here three ports. I have 9 interconnected intersection connections. So if two of those devices, they send the data through the memory, which is an old switching techniques, what we have to do, as I mentioned, we have to create something called queuing. Queuing where? In the memory. So if the data came over here, it has to come to the memory and then output. All right, what about if multi frames arrive at the memory and the memory area become full? So it has to be hold. You get to hold. So what we have exactly here, that's a switching via the bus, as you can see here. And this is switching through the interconnected. What happens exactly if I have the port I want to switching fabric? But now if I want to, in the old memory, we have queuing. You have to go in queue. And queue means slow. In short, that's easy as that. So in the memory, I have to put everything. And as you know that usually the memory buffer usually has limited size. So multi-buffer comes in, multi-frames comes in, go to the buffer. The buffer full, you have to wait outside. Even the one inside, if you are packet number 10, for example, you have to wait for 1 to 9 to be cleared. That's longer time. So what they came up with, we have something called HOL, which is the head of line blocking. In short, an easy task. If the out, if the out, the outer port can take one packet at a time. If I try to send this one and that one at the same time, so port number one want to send it, port number three want to send it to the same port, which is port number one out. So port number one out cannot take more than one packet. So what that port will do, we have a mechanism, technique called HOL, which means that I'm gonna take this one, block this one, which means that keep it in hold for a while, block this one. Later on, after I process this one, that one can come over and be processed. That one can be goes to another port. The green one, which is over here, now after I process the red one, the green one can jump in and then start being processed. It's an easy, simple technique. When I have more packets, more frames, then I can handle, I need to block some, which is until we call that the head of the line. I got you something here, which is, you can see that this is the datagram buffer, and then the data link layer protocol, line termination. It's away from here. It is something like example like that. We haven't put you the full material over there, but just in case if you want to have something like that. You have blue, green, and red. Here, two reds, they want to go over here. We have to take one packet at the time and block the green one, and so on and so on. So if you have more than one, and I can process two here, I'm going to take one from here, one from here, and keep one for the later on. That's away from a little bit, maybe not away from the material here, but it's better if you get the whole idea so you can be aware of what we covering. So to go back to the switching, we use the CSMA CD, what we call that carrier sense multi-access collision detection. And we have a better version, which called collision avoidance, CA. That protocol usually, it was developed to work for wireless. Then we start using that because it has to avoid wireless technology based on avoidance. So we start to develop a version of that to use it on the wired links as well. So the collision avoidance. One of the good thing with as well with the switches, what we call it plug and play. I think I demoed that last session. If anybody still remember, we have here something called Mac. As soon as you plug the cable here, if I put another one here, for example, oh, if I put another cable here, and I put a switch like that, for example, as you can see that it started communicating and start learning the port, learning the MAC as well in some cases. If we configure that to learn dynamically, that switch can learn even the MAC address dynamically without any problems. As we mentioned as well that, and I have demoed that online last session. We have A, B, C, D. That switch over here, I want to send from A to C, A to B, A to D, whatever you want to send. Those ones, the communication between an A and B, isolated from A and C, isolated from A and D. So if something happened when you communicate that, didn't affect anything with the other devices except if you are here. Another thing which is when we try to if you link four devices like that, you will find the MAC table, and the MAC table usually provide you with something like this. What we have here, that's self-learning. Self-learning means like the switch will self-learn the MAC address, the interface, and the TTL, that's another story. However, it gives you the forwarding technique. So, for example, let's say A want to send the data to B dash, right? Okay, so what A will do will send the packet or the frame into the switch. The switch will do a lookup right away, which is few milliseconds. We'll search right away, look at the MAC table, and oh, that packet directed to that MAC address. All right, which interface is that? That's number 5. Put it to number 5. And so on and so on. So it's actually easier. We have a self-learning, we have a build-up MAC or CAM table inside as well. And we have isolation. So if A want to send it to B and C want to send it to D and so on, it didn't affect anybody. It's multi-transaction at the same time. And imagine if you are in the lab at the university. Usually the lab, by the way, your computer connected through the walls, underground to the wall, then it goes to the switch. So you're sitting and your classmate sitting, and everybody tried to do something on computer, all of it communicated to the same switch, same switch. However, different ports. You do not affect your classmate didn't affect you. Very quick switching from one port to another port through the CAM table, and there is no collision fully. What else? That's a traffic isolation. Head of the blocking. The interconnected switches, which is, in my opinion, that's a good approach to learn. You can see that here it is, for example, watch that. Let me just show you that how we do something like this. To do it in a correct way, let me show you what to be professional in that one. Let's go for the PCs first, and then I'm going to show you why I removed that cable. For those who want to learn what's that exactly. So here, put from any ports, whatever it is, doesn't matter for now. Here as well. Here. And here. Just to understand why I removed that, because usually we have, if I'm linking a switch to a switch, we usually use crossover cable. That's the one with dots. If I'm linking similar devices, not just only in case. If we link similar devices, we prefer to have a crossover cable, which is this one. So what we do over here, this is what you can actually see in a professional networking company or corporate or even university. What do you mean by that? We have layers of switching, layers of switching. So you have that like this. Oh, really? Yes. And we can make it higher. So one switch can be higher like that. Yes, we can make it like this. And let me just show you. So we can make it more complex like this. So I can put another switch here, which is another layer if I want to. So, and then I start to connect it those ones. If I want to have high availability, if I want to create high availability, we do something like that. Then if I want to create another level, I can create another level at the top as well. Really, yes, we do that. However, those switches, they can talk to each other. Here it is. Just let me make sure that to here. And if I try to ping a device from here to here, for example, with an IP address, you will see all the packets or all the frames been sent to that switch. From that switch is gonna go here and here. From here, it's gonna goes here and here. It's gonna goes from there like this. It's gonna be everywhere. So then finally, so they talk to each other, sure. So for example, if this one is 192.168.10.5 and this one 10.15 or 10.12, it's gonna goes here, then here, then here. This one will pass it here and here. Then one will pass it to this, to that. Then finally, this computer only, all those ones will drop the packet except this one will return back to the switch over here, and all those ones will be updated with the MAC addresses. I had show you some demo like that last week. So where we put the switches inside the network usually to understand why switches are really important for us. Switch is usually what we do. We have at any network, we have a router. Usually the router, not just one router, don't get me wrong. They usually have more than two routers and more for high availability and so on. But away from here, let's assume that you have a router. Usually that router has, before the router has a firewall, and after the router has another firewall. Really, yes. One before, one after, like this. However, let's say assume that we have a firewall or we have another layer, let's say layer 3 switch. What we do usually, I'm going to put here just only for that, for the sake of the demo. Here it is. That's layer 2 for the sake of the demo only for now. So here it is. I'm going to link it. Let's say you want to link it to that high one. Okay, here it is. Then I will link this one over here. And in that area, usually what we put servers, all the servers we have, everything we want to put it outside to the outside world. And we call that we call that the DMZ. And after that, we put another firewall to filter the data to the internal link. But the idea here, which we want to focus on for today, the rule of switches. What is the rule of switches here? Well, do you see that one here? Instead of using a layer 2 device like this one, usually what we do, we use the layer 3 device, which means that instead of putting layer 2 switch, no, we're gonna put a layer 3 switch, 3560, for example, put any one of them here. And this one take us to the main core area of the today, the VLAN. What is VLANs exactly? In professional networking, here it is. That's, let's say that's coming from here to here. This is the university, for example, campus. This is a layer 3 switch. The layer 3 switch usually connected to different layer 2 switches. That switch can be connected to switches. That one specifically can support switches and very fast and very professional, layer 3. So with this one, we can use it to create VLANs through the network, the university network, or the college, or the campus, or any company, corporate, whatever it is. What we usually do to implement something like that. If I wanted to do a VLAN, which is um, if I want to do a VLAN, what to do exactly? VLAN is a function which is based on grouping devices sharing the same functions, not the location. What do you mean by that? Okay, so let me just make sure that to get that. This one, I'm gonna put this one in something called VLAN 10. And this one, you can say that this is IT department. And this guy for VLAN 20, that's the HR. And this PC, let's say VLAN 30, and those ones are the academic. Okay. So, and that one, the switch in building or in floor, if you are in the same building, let's say this is in the second floor. If they are not in the same building, this is, let's say this is whatever, the building number 4, and this switch located in building number 7. But the IT, if they want to send the data, and which is usually, let's say, a broadcast data. If I want to send the broadcast data to search for someone, what will happen? Oh, okay. Those ones are going to be sent to the switch. The switch will flood everywhere. Everywhere will flood everywhere. The whole switches will be floods. That's a lot of traffic, which means that you're losing resources. How to go around all those problems? Oh, this is not the only problem with switches. Really? Yes. So what we can do about that? We have a problem with the switch when it comes to broadcasting. What do you mean by that? Right. Let me just make sure that to get that. And that's a switch. Link to another switch. Link to another switch. Let's say link to another switch. Here it is. And those ones are linked to another fifth switch or something like that, like this. Now, switch number one wants send a broadcast. Okay, it's gonna send here and here and here. What that switch will do, will send it to all the port except the port which is coming from. So forget about this one. I'm gonna send it here and I'm gonna send it here. Okay, but we have a problem. Yes, that switch will send it, assume this is the one here, it will send it to this switch. Okay, that's switch number two. It been arrived to that port. That port, okay, so that switch will send it this direction and that direction and that direction. Okay, let's focus in that one only here for switch number one. I send you a frame to be send it to the switch number two. This is switch number three. So you send it back to me, which is this one. It arrive on that port. Okay, I'm gonna send it again to that port and that port. It gonna goes over here and send it back again like this. Keep going like that. And this is only between three switches. So if it's gonna keep looping like that, wow, what will happen? One, it will consume the resources, the CPU and the RAM and everything. After a few minutes, you will find your computer or your device start to freeze because all the resources being consumed. And later on, few minutes later, the device will not be interacted. So whatever you do in it, it will not goes anywhere. And the only solution that you have to shut down the power off to stop that loop. So what we can do to stop that? We have something called STP. You may have seen something like that here. What are those orange ports? Away from this lecture, but the idea of that is we do plug some port, we do assign something called priority, we do assign route, what the boss, the boss switch, and then we have something called designated port and then alternative ports, and then support sometimes we shut it down if we want to. Who does that? A protocol called STP, Spanning Tree Protocol, designed first. The orange one here, what you see right now, that's actually by a protocol to prevent looping. The algorithm designed to prevent loops. So that's one. So in terms of broadcasting and the problem which we face with broadcasting, we have a protocol called STP, which can stop that. So why we prefer to still using switch? One, I told you, single collision domain for ports, faster. Even the data, when it move into the switch and move out of the switch, has techniques. What that techniques exactly? Let me just show you. Maybe we have the two famous techniques, which is the data goes in and out of the switch. The old one, we call that store and forward. Watch that one. The store and forward, look. What happened here? The whole frame, the header, the data, and the destination MAC, everything, the whole thing goes first inside the switch, then goes into the memory, then goes out. And that's slow, create delay. Why is that? Because you put the whole frame, everything, the header with the data. The header, the frame size usually start from 64 byte until 1518, which is big. But the one which is we talk about here, that the MAC address, that is the source and destination and all that. So I have to put the old system. You store the whole frame value inside the memory, then goes out. So everything goes in, search for read the header, then find out what the destination, then push it back. In short, you put something inside the memory, then all of a sudden you take it out of the memory, put everything in the memory outside of the memory. That's an old technology, which is slow technology. So they did improve that and they come up with a better technology. We call that cut through. Watch that and see what the difference. Can you see that? That's the source MAC only. Source MAC, oh, I'm sorry, that's the destination MAC only. The destination MAC only, it's 6 bytes, 48 bits, 6 bytes only. That's what I need to read. So the switch will read only part of the header, which is that where you go, this is your destination. Let's go. So forward you to um, the destination. So I do not, as a switch, need to take all your data, put it inside the memory, then outside the memory again, which is going to create, as we mentioned, inside the fabric, or if you want to do HOL or queuing, delaying, and so on. We don't want to create that. So the difference between store and forward and cut and through, store and forward, you have to put all the frame inside the memory. Then you look up and then send. The cut through is not. The cut through, you just only look at the switch, will look at only the MAC address for the destination, which is 6 bytes only. And after that, where you go, here it is. Is that faster? A lot faster. And that's um, advantage of the cut through over the store and forward. So let's go back again to the same area. Why we do prefer switching? Isolation, no collision domains, only per port, faster, secure, yes. You may have experienced that, maybe not, but we can implement a lot of level of security on the switch. Really, yes. One of the areas which is as well which is interesting in when you study switching, what we call that a VLAN. The VLAN, if you want to group devices by functions, not by locations. In short, if I have here, if you want to see something like that, this is the building. Let's assume we have all in one building only. That's it, not multi buildings, and we have floors. And each floor sure has normal switch, which is layer 2 switch. Usually we link those ones, all of them outside here like this, to a layer 3 switch. Layer 3 switch. But anyway, away from that concept for now, but let's say, so you have floors, those floors have switches. Inside those floors, you have some employees who work for the IT, some people in the third floor IT as well, some people in the first floor IT. What about the admin? Some people admin here, some people admin in the ground floor, some people admin in here. What about the academic? Oh, we have academic, We have an academic. We have an academic here as well, and we have academic here as well, and so on and so on. Keep going like that. So what we do as a VLANs, VLANs, we come to the switches and we said, okay, what about if I grab those guys, the red ones, which is the IT, and we, through the switches, we group them, three of them, under one VLAN, and we call it IT, for example, VLAN 10. Okay, so, and we grab those ones, the green ones, VLAN 20, those are, let's say, the HR, and we grab them here under the switch as well, using the switch, and that's VLAN 20. Really? Yes. So what's the point here? Here it is. If I want to implement that into that's a switch, that's another switch, and this is PC, that's PC, that's another PC, that's another PC. Oh, sorry, that's a switch. That's another PC, that's another PC. And from here, we can link those together. And from here, I can link those guys, whatever it is. That's 24. That's 23. Over here, 10. And here, 11, let's say. Okay. Right. This one, that's VLAN 10. And this one, VLAN 20. Those guys in another building, assume this one in either floor or building. This one, building A. That's building B. And those are in two different buildings, okay? That's switch 1 and switch 2. And they want to talk to each other. Why you said something about that, why they want to talk to each other? Okay, if I have employee here in the IT department want to talk to someone in the that's the VLAN 20. Here it is. If someone in building A want to talk to someone in building B, whatever it is, but from the IT, can we grab those together? Why is that? As I told you, less broadcasting. So imagine if you send a broadcast to the IT department only, or you send a broadcast to the IT with the HR, with the academic, with the sales, with the management, with. So it's less traffic and more secure. So I can put the payroll talk to each other through the switch. They do not need routers. So the IT, they can talk to the IT in another building, in another floor. They can be together. They send the packet, they send the frames, they send whatever they want to send, data between one to one. No problem, no problem. And they can broadcast as well for limited number of those the VLAN members. So less broadcast if I want to use broadcast, secure if I want to provide security. Why the packet of the payroll goes into with the packet for the IT or the HR or the academic or whatever it is. All right. So what about if the IT want to talk to the HR, for example, if VLAN here or VLAN, let's say this one, VLAN 30, let's say. If I want someone from VLAN 10 want to talk to VLAN 30, now the switch here will not be able to do so. So what we do, we add a layer 3 device and we implement something called inter VLAN, which I believe that you have implemented that in one of the labs, but you have implemented that using GNS3. So what we do, we create here two different interfaces. This is, for example, gig 0. So we put gig 0.10 and we put an IP 192.168, let's say 168.10.1, and that's /24. And we put G /0.20, and we put an IP 192.168.20.1/24. We configure that using technique called encapsulation, the .q1. So we encapsulate that inside the interface. We call it that sub interface. We declare those port, this one, that one, that one, the mode as strong, which you have coded that within the lab, by the way, but we put that as a trunk. That one, and this one as trunk as well. And this one, usually we put it as trunk as well. We do not leave it for that. 3 of them. The end devices port, that's access. The mode is access. However, to make that PC be able to talk to that PC through the switch, you have to assign that port, which is port, for example, in my case here, I put that in port number 24, like that. So I have to assign this port into VLAN 10. What about this one? VLAN 20. So that port belong to VLAN 10, which is excellent. So in one of the here, that's from the top-down approach textbook, we can divide the switch based on ports. So I can put, for example, port from 1 to 8 VLAN 10, and I link the cables into that. And then onto the configuration, I assign those ports, all of them, to VLAN 10. From 9 to 16 to VLAN 20. From 17 to 24, VLAN 30. That's how it is. Switch port mode access. That's the command, by the way. Switch port mode access. Then we assign it to the VLAN we want. So is that actually a better one? Yes, watch that. So I got you something similar to that. You can see over here, that's VLAN 10, those ports. Then we have VLAN 20, the green one. Then we have VLAN 30, the little bit orange. Then we have the light blue VLAN 40 on the same switch. Yes, something like that. So can you see that when a packet arrives to VLAN 20, as you can see that only VLAN 20 will be aware of that packet, that can reach to that packet, a VLAN 20. Similar to that, when a packet come to VLAN 30, VLAN 30, VLAN 40, VLAN 40. So you see, you can tell that VLAN 10, VLAN 30, VLAN 40, not aware at all of any arrival frame or packets or data arrive to the switch. Only VLAN 20 aware of that. Only. Something similar to that here as well. We tried to show you that's the VLAN 10. I can put here, that's a virtual, by the way, as you can see that inside the physical uh, switch. Imagine if you create inside the switch actual virtual switching. That's why I call it VLAN, virtual LAN. So what we create exactly, we create virtual switch inside a physical switch. That's how it is. That's how it is in an easy concept or techniques if you want to follow. How we do that, something like that, we have something called the encapsulation, which is the 802.q. Away from your the lecture for today, but we do encapsulation. What's encapsulation? See this one? Can you see that? Let me just maybe here. You see that when it comes to 10 and 20, what is that? That's the VLAN 10 and that's the VLAN 20. You can see we have something called tagging. So that's VLAN 10. Oh, this packet goes for VLAN 10. It's gonna go to VLAN 10 only. That VLAN 20 only, and so on and so on. So each packet has different number. We call that tagging. That's one of the excellent technique with the VLANs. Um, Port post VLAN, dynamic membership. VLAN benefits put whatever you like. And in my opinion, one of the top things is security, data isolation, traffic isolation, reduce traffic, many things. Like you can write, say whatever, many things. One of the areas as well, this is the institutional network. That's router, a switch, link to different switch. This is usually we prefer to have that layer 3 switch. However, we haven't show you here the firewall. Usually we use firewall before the router, one after the router, and then we put a switch, another switch, so to isolate the DMZ from the internal network. However, for the sake of the concept only, we put you everything here in one diagram. So you have in the switch, you have the mail server, the web server, and then you have here, I can put um, a specific, let's say, department if I want to, or I can mix them together. That's not big issue. If I wanted to put this one, for example, the whole department here, IT, the whole department here as HR, I can do that. However, if I want to mix them through, there's no problem at all. I can do that with the VLANs still as well. Even if I connect to another switches, another buildings, wherever, we can do that. One of the thing which is privacy, efficiency, yes, well, there's no problem with that. I'm trying to cover you the whole thing, but I add you few material from my site just only to give you the whole, not the whole, but it's that's the one I mentioned to you before, the transmission delay, and that's the L by R. So that's what the why we come to the cut through, because the longer the length of the frame, the delay will be, in short. And that's the transmission rate, or what you guys call it, bandwidth, or the speed in your own terms. So if you want to compare between switch and hubs, switch at the top for sure. Switching usually has high level of security, high level of speed. Um, it has features like VLANs, excellent one. We can use it for that. It has term of encapsulations. It helps us. We do a VLAN. Oh, by the way, one of the since we are here in the same page, the example which I mentioned to you here about the building, which we do something like that. What we do if you want to see how it works, if you have a building, for example, and you have a company or whatever it is, if we assume this is the internet, the data coming from the internet here, what we actually require, yes, we require a firewall first, then we require, let's say 1941 model router, and after the router, we require a layer 3 switch, which is this one. From the layer 3 switch, that one can link, here it is, imagine this is the building, if that's one building. But if you different buildings, it's okay. So what we have something like this. We came from the router to the switch here, and let's say here it is, and from here, those guys, they connect to each other from whatever it is. Let's say here to here, and this one. And keep going like that, whatever it is. That layer 3 device like that, or sometimes we link it instead of one like this. By the way, we have multi-links. What do you mean by multi-links? I can have something like this. So I have for high availability, for whatever, I can have something like that. So those are the layer here. And this one, they need to have a special, okay, here it is. And then you connect that to the internet. And this one represent a floor, a floor, a floor, a floor, or building, 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 whatever you like. So that layer 3 switch, as you can see that, can support 24 switch. Again, we use that excellent for if I want to do an inter VLAN. If I want to create VLANs over a big, massive network, we use layer 3 switch. We can use this one to communicate here. Each one of those switches, each one, support 24 PC, for example. That one support 24 PCs. And this one, the same thing, 24 PCs, and so on. Here it is. And this one as well. And this one as well. So one layer 3 switch can support 24 times 24 device. 24 times 24. So with different VLANs, VLAN 10, 20, 30, 40, 50, 60, and separate the devices, do the trunking and everything. So those devices, imagine if you are in a big corporate, you can tell that the IT, they talk to the IT, HR with HR, whatever, the data is isolated, high level of security, low level of broadcasting. So it's faster and secure. That's what we need to cover fully for today. Questions? Questions? No? Okay. If you don't have any question, have a good day, and I'll see you next week. Let me figure out or find out that if next week will be a public holiday or not, I need to contact Rockhampton. Have a good one, and I'll see you next week, hopefully.